For practice set 3, I wanted to show you guys how to make both simple and grouped frequency distributions using single and multiple criteria. And then we'll be using some other Excel formulas and functions that we haven't covered yet. So you'll go to the practice 3 sheet, and then the first thing we're going to do is sort our data by adding a filter and then specifying what type of criteria we want to sort our data by. Then we'll create a simple frequency distribution for our pull-ups and a grouped frequency distribution for the plank times. We'll get more into what frequency distributions are in later weeks, but for now, this is kind of just an introductory thing for us to have an example for. So the first thing in your instructions is to add a filter to the data labels for the swim team fitness outcomes. So the data labels are name, pull-ups, plank time, push-ups. If we go over to this little magnifying glass icon, we see sort and filter, and then you can apply a filter from there. Filters will show up like with little drop-down arrows. And then I want you guys to sort the data using some various methods. So we can either sort information by clicking on a drop-down arrow and then saying, let's say I want to sort people by their ascending pull-ups. Okay, so now all of these people have been reorganized based on the number of pull-ups they were able to perform. I could do the same thing with push-ups, but maybe I want the greatest number of push-ups at the top and the smallest number of push-ups at the bottom. Okay, this would be how you could organize your data based on a single set of criterion. We could also apply multiple criteria by doing a custom sort. So if we go back to this magnifying glass, sort and filter, custom sort, I can first say I want to first actually make sure that this box is checked, that your list has headers, because that will recognize the headers as your name, your push-ups, plank time, and your pull-ups. But let's say we first want to sort people by the number of pull-ups they can perform. So we'll put pull-ups first, smallest to largest. And then let's add another criterion. So sort by pull-ups, smallest to largest, then by. We can put in push-ups from smallest to largest. And then we press OK. And then now you can see we've sorted people first by pull-ups, then by push-ups. So this is helpful sometimes when you've got people who have the same value for the first criterion, but you further want to sort them by values based on the second criterion. So we can see for people who had one pull-up, they have also been sorted by smallest to largest in the push-ups category. I want to then create a simple frequency distribution for pull-ups going from the minimum number of pull-ups to the maximum number of pull-ups. So a new formula we haven't used yet. If we want to find the minimum of a range of data, we put equals min. We can click on this function or just type our parentheses to start our function. Okay. Now, this is more so useful when we have a larger data set that is not filtered or organized. Clearly, you guys could probably look at this and say the minimum number of pull-ups is 1 and the maximum number of pull-ups is 20 because we've already ordered people from smallest to largest. But if we wanted to find the minimum within a range of data, we put our min function, insert the range, and then press enter, we get the minimum value. If we wanted to find the maximum value, we put equals max, identify the range, and we get the maximum value. So those are two functions that you might find useful one of these days. I'm going to label this section my simple frequency distribution, just so it's separated, and I'm just going to format it this way. So in a frequency distribution, or a simple frequency distribution, we look at a certain set of criteria. Usually it's the same unit change from one criterion to the next. So in this case, we're going to have number of pull-ups from our minimum to our maximum number of pull-ups. So I can make this list all the way to 20. And then the next column in our distribution is going to be the frequency, or how many people were able to perform a given number of pull-ups. To calculate this frequency column, we are going to use a function called a COUNTIF function. And what that function does is it will return the number of cells, or the count of cells, that meet a specific criteria you enter. So we're going to do equals COUNTIF. We then see it's asking us for a range, so we want to count within the pull-up data, comma, and then we put a criteria. So for the frequency for the people who performed one pull-up, my criteria would be 1. So basically this function would read, count the number of cells within this range that are equal to 1. I can put a parentheses, and then if I'm thinking ahead, I will want to copy this function downwards for the rest of the pull-up values in my distribution. So as I copy downwards, my cell references will also shift down. Now the red reference for the number of pull-ups, I want that one to shift every single time. That way I'm counting based on the criteria of each given number of pull-ups. However, I want this cell range to stay the same. So because I'm copying downwards across rows, I need to put a $ in front of the row references to make sure that those rows don't change. Or in other words, to make sure that this blue box doesn't keep shifting downwards every time I copy my function down. So I can press enter, and then you can either click and drag, or I also wanted to show you guys another shortcut that you can do. If you have a column of data that have a certain length to them, and you're copying a function downwards next to it, if you hover until you get your black plus sign and double click, it should autofill up to the end of that range next to that column. So now we can see that we've got 2 people who did 1 pull-up, 2 people who did 2 pull-ups, right, and then so on and so forth. So again, when you're copying functions, I always recommend that you double-click on at least one of your cells to make sure that the formula worked and is still representing the same ranges and values that you want, which it is, so that's great. And that's how we create a simple frequency distribution. I also wanted to show you guys how to create a grouped frequency distribution. So I'm going to label that one over here. And this one I will make blue. And for a group frequency distribution, instead of having a single criteria, we have multiple criteria based on a lower bound of a group and an upper bound of a group. So in your instructions, I've asked you to create a grouped frequency distribution from 35 to 105 with group intervals of 5 seconds, basically, because we're looking at Planck time specifically. So as far as our column labels, we're going to have a lower bound, an upper bound, and then we'll have the frequency that we are calculating with our formulas. The lower bound is going to start at 35, or that's the smallest value in our first group. We're increasing by intervals of 5, so the next value in that row, or in that column, would be 40. And then I would be going to 100. This group has an interval of 5, so 35 to 40. We still have intervals of 5 coming down, and then we should be ending at 105. So I've now created groups that represent intervals of 5 from 35 to 105. Now I want to calculate how many people landed in each of these groups based on their plank time. So because I have multiple criteria, instead of using a COUNTIF function, I will now use a COUNTIFs function. S meaning plural, multiple criteria. So we'll do equals COUNTIFs, put our parentheses. It'll ask you for your criteria range 1, which will be my plank time. And then I'll eventually copy this downward, so I'll just go ahead and stick in my $signs as I go. I put a comma, and then I put the first criteria. In your instruction sheet, I specified that I want you to include or have an inclusive lower bound and exclude the upper bound. The reason being is that you'll notice each of the upper bound values are repeated as a lower bound value in the adjacent group. So if we had somebody who did a plank time or had a plank time of 40 seconds, if we included both the upper and the lower bounds of these adjacent groups, that person would end up getting counted multiple times. So when you create frequency distributions, if your upper and lower bound values end up being the same for adjacent groups, you have to include one of those values and exclude the other one. That way you're not adding people to your sample size. So in this case, my first criterion for this cell range is going to be anybody who is inclusive of my lower bound, so greater than or equal to 35. To type this, we're going to put a quotation mark, greater than, equal to, another quotation mark, and the cell reference, or that matches the criteria you're trying to use. Then we'll put a comma, and you'll see our syntax is now asking for criteria range 2. It's going to be the same range of cells, and then I'm going to shift to my formula bar so we can see what I'm typing. I'm going to put a $sign in front of the row references, so that way when I copy my formula downwards, it's not going to shift this blue section. I'll put another comma, and then now I want to be exclusive of my upper bound. So that means I want all of the values that are less than and the upper bound. Okay, so all in all, this formula is going to tell me how many cells within this given range are greater than or equal to my lower bound of 35 and are also less than my upper bound of 40. So I press enter, and I end up seeing I have one value that matches that set of criterion. I then can copy that formula. If I wanted to double check, I need to make sure this blue range stays the same on all of my plank times, and then make sure that the lower bound and upper bound of the group I'm trying to calculate the frequency for match in the formula bar, which they do. So that's cool. All right. So that's how we do simple and group frequency distributions using COUNTIF and COUNTIFs functions.